Quarter 3 review trig functions. So we have SOHCAHTOA, where we have sine based on the angle theta. So theta is right over here for us next to A. And based off of theta, we want to label our triangle. So we can see here that angle C is a right angle. Therefore, the side AB is going to be the hypotenuse, which is always opposite of the 90 degrees. And then for theta, if we go draw a line through the middle of the triangle and we hit the other side, that side is our opposite side for theta. And then the last side is the adjacent side. We can see that sine is opposite over hypotenuse, cosine theta is adjacent over hypotenuse, and tangent theta is opposite over adjacent. SOHCA for sine, ka for cosine, and then toa for tangent. So given the triangle, write all 6 trig ratios in terms of angle x. So here is angle x, which means if we're going to start labeling our triangle, start off at the 90-degree angle, draw a line through the center, the side you hit is your hypotenuse. Start at the angle we're talking about, which is going to be angle x, draw a line through the center of your triangle, the side that you hit is the opposite side, and the last side is the adjacent side. So if we're going to write our 6 trig ratios, we're going to start off with sine x, which is going to be opposite over hypotenuse. So 12 over 37. And if you can reduce the fraction, reduce the fraction. In this case, we can't. Then we have cosine x, which is going to be adjacent over hypotenuse. So 35 over 37. And then tangent x is opposite over adjacent. And then we have the reciprocals. So we have cosecant x, and all that is flipping the fraction for sine. So it's just its reciprocal. So it's 37 over 12. And then the reciprocal for cosine is secant. So it's just, once again, flipping the fraction. So we have 37 over 35. And then we have the reciprocal for tangent, which is called cotangent. And once again, flip the fraction. And those are your 6 trig ratios. All right, use a trig ratio to solve the missing side of the triangle. So this is where you want to start off with labeling your triangle. Starting at the 90 degrees, draw a line through the center. The side you hit is the hypotenuse. We have a 66 degrees here, so everything's going to be based off of this angle where the 66 degrees is. If I draw a line through the center of the triangle, the side that I hit is my opposite side. The other side is called the adjacent side. So given that I have a hypotenuse and an adjacent side that is cotangent, 66 degrees equals adjacent over hypotenuse. And from here, I'm going to solve for x. So I'm going to multiply both sides by my denominator, which happens to be x. Here, the x's are going to cancel out, leaving x times cosine 66 equals 15. We want to get x by itself, so we're going to divide both sides by cosine of 66. And so we are going to be left with x equals 15 over cosine 66. And we're going to type that into a calculator. 15 divided by, hit the cosine button, 66, close parentheses. And you're going to get about 36.9 if we round to the nearest tenth. So this right here is 36.9. All right, use a trig ratio to solve the missing side, round to the nearest tenth. Once again, we want to start off with labeling our triangle. So we start at the 90 degrees, draw a line through the center. We're going to hit the opposite side, which is known as the hypotenuse for that 90 degrees. Then we're going to start at the 65 degrees, draw a line through the center, and we're going to hit the opposite side. And the side that's left over is the adjacent side. So this time, we have the opposite side and the hypotenuse. That's going to be sine. Using 65 degrees, the opposite goes on top, the hypotenuse goes on the bottom. We're going to get x by itself by multiplying by the denominator. The 20s here are going to cancel out, leaving x equals 20 times sine 65. This is where we're going to use our calculator. 20 times sine 65, we're going to get 18.1 when we round to the nearest tenth. So our opposite side is 18.1. Okay, this says use a trig ratio to find the missing angle, round to the nearest tenth. So if we want to find angle measures using our trig ratios, we're using these buttons on the calculator. Sine with the little -1, cosine with the -1, and tangent with the -1. So first, we'll notice that this triangle has all three sides, so we can choose if we want to use sine, cosine, or tangent. You get to pick which one you want to do when this happens. I'm going to choose for the first one, I'm going to use tangent. So to get this button on my calculator, if I'm using one of the nice blue ones that I give you, you're going to hit the second button, then you're going to hit the tangent button, and on your screen, you're going to see tan with a little -1 that's parentheses. Now remember, tangent is the opposite side over the adjacent side. So I'm going to have these two numbers. Opposite side on top, divide the adjacent side, and you're just going to type that into the calculator. So we're going to hit second tangent, 42 divided by 40, close my parentheses, and I'm going to get 46.4 when I round to the nearest tenth. So that angle, where the question mark is 46 degrees and 46 degrees 0.4. All right, let's take a look at the one below. Let's use a different trig ratio. This time, why don't we use sine? So once again, in labeling the triangle, across from the 90 is your hypotenuse, across from the angle is your opposite, and the last one is the adjacent. Since we're going to do sine, we care about opposite over hypotenuse. So once again, I'm going to hit the second button on my calculator, and this time I'm going to hit the sine button, and on my screen I'm going to see sine -1 with a set of parentheses. And then I'm going to go ahead and do opposite over hypotenuse, so 24 over 30, close parentheses. We go with the calculator, second sine, 24 divided by 30, and you're going to get 53.1 degrees for that angle. Alright, so an air traffic controller at an airport sights a plane at an angle of elevation of 41 degrees. A pilot reports that the plane's altitude is 4,000 feet. What is the horizontal distance between the plane and the airport round to the nearest foot? So imagine we have a dashed line. And when we do what we call angle of elevation in depression problems, and you'll usually know because they'll have the key word in there, elevation or depression, I always recommend you start off by drawing a horizontal dashed line. Now this says there's an angle of elevation of 41 degrees. Elevation means up. So I'm going to look up. And when I look up, there's this 41 degrees here between my dashed line and looking up. Up in the sky, there is a plane, and that is 4,000 feet in the air. That's the altitude. Now the question's asking, what is the horizontal distance between the airport, here's my airport, and the plane? So this is my horizontal distance. Horizontal distance is a flat line, in this case, our dashed one. And so we're just going to solve. We're going to solve for that x. So once again, you always want to label your triangle. If this is my right angle, going across in the middle of the triangle, this is the hypotenuse. The angle they give me is the 41, so if I draw a line through the middle of the triangle, the 4,000 ends up being my opposite, and the x ends up being my adjacent side. So in this problem, I am given the opposite and the adjacent. And so that trig ratio is tangent. So I'm going to have tangent 41 degrees equals my opposite, which is 4,000, over x, which is my adjacent. I'm going to multiply both sides by the denominator. And so the x's are going to cancel out, leaving 4,000 here, x times tan 41. And then we're going to divide both sides by tan of 41. So x equals 4,000 over tan 41. And this is where we're going to go to our calculator and type that in. So 4,000 divided by tan 41, close parentheses, and we're going to get x being 4,601 feet. And so that will be the distance from the airport to the plane, the horizontal distance. All right, so a forest ranger in a 90-foot observation tower sees a fire. The angle of depression to the fire is 7 degrees. What is the distance between the top of the tower and the fire? Round to the nearest foot. So once again, I'm going to start off with a dashed line, the nice horizontal one, but this time it's an angle of depression, so I'm looking down 7 degrees. And when I look down, that's where the fire is. So I'm going to create myself a triangle out of this. Here's my tower. There's the tower. And we know that the tower is 90 feet tall, which it tells us up here in the story. And so we want to find the distance from the top of the tower to the fire. So we're trying to find this right here, the hypotenuse of the right triangle. So before we can actually solve this problem, we actually need to find out what this angle is. To use our trig ratios, the angle degree they give us needs to be inside the triangle, and we currently have our angle degree outside the triangle. Now, one thing that we got to review is that when you have a vertical line, like a tower going straight up in the air, and a horizontal line, which is our dashed line, it creates 90 degrees up here. So if this is 7 degrees, and we know the total between these two have to be 90, this would end up being an 83-degree angle. So now that we know that's 83 degrees, once again, label your triangle. Start at the 90 degrees. The side opposite of it is the hypotenuse. Then we start at the 83 degrees, draw a line through the center. This is our opposite. And the last one is our adjacent. So this time they have provided the hypotenuse and the adjacent. That is the cosine function, 83 degrees, equals 90 over x. I'm going to multiply both sides by x. The x's over here are going to cancel out, leaving 90 equals x times cosine 83. Divide both sides by cosine 83. Those are going to cancel out. And so we're going to type in 90 divided by cosine 83. And we're going to get 738 feet. So the distance from the top of the tower to the fire is 738 feet. All right, so the geometric mean of a right triangle. So you may remember this kind of picture at the beginning of the third 9 weeks, where they are giving us a right triangle, this big one, and then an altitude, which is the height of the triangle, for segment F. Now, if we want to be able to solve for any parts of this triangle, there's a few different things we can do. Say we need to find one of the sides, D, F, or E. If we got to find one of those lengths, we're going to set up a proportion, which is an equal sign with a fraction on either side. Now, the altitude, the F in this picture, is always going to show up twice. So it's going to show up on the top in one fraction and then the bottom in the other. It doesn't matter which order you do this in, as long as it's on top in one and bottom on the other. The D will show up in one fraction and E will show up in the other. And this will allow you to solve for either one of these sides. Now let's say you want to figure out one of the lengths for A D or C. Once again, I'm going to set up a proportion. The A will show up twice. It'll show up on top in one and bottom in the other. The D can show up in one fraction, and C has to show up in the other. Once again, it doesn't really matter the order as long as A is diagonal from each other in the fractions. All right, and let's say you want to find one of the sides that's B, E, or C. Once again, one of them has to show up twice in the proportion, and it's always the one that you see that I'm circling. So in this case, I have my equal sign. I'm going to put B on top, B on the bottom. The E will go in one fraction, the C will go in the other. And then we will be able to do some math to solve for these, which you're going to see in your next example. But this is the setup. This is what the picture looks like. In my opinion, it kind of looks like a butterfly. Here's the little head popping out. There's its wings. Here we go. All right, it says use the geometric mean to find A, H, and B. So I'm going to start off by first making sure that I know the length from here to here. That's the one thing you always want to know if you want to find B or A. So we need to know 6 plus 8 is going to give us 14. Okay. So let's start off with finding H. So if I want to find H right here is our altitude, which means it's going to go to 6 and 8. So I'm going to set my proportion. H is going to show up twice because the one in this position always shows up twice. 6 will go in one fraction, 8 will go in the other. Now to solve for H, I'm going to multiply across. So I'm going to have H squared because H times H. And then 6 times 6 times 8 is 48. To solve for H, I'm going to square root both sides. And the square root of 48 is 6.9. Now I'm going to go ahead and solve for B. And so B goes with the 6 and the 14. So I'm going to go ahead and set up another proportion. Once again, the B is going to repeat itself because the one in this position always repeats itself. And then I'm going to put 6 in one and 14 in the other. Once again, I'm going to multiply across. So B times B is B squared. And 14 times 6 is 84. Going to square root both sides. So B equals the square root of 84, which is 9.2. And the last one, once again, this position, that gets repeated, and it's going to use the number 8 and then the 14. So once again, I'm going to set up a proportion where the number that's in this position, which happens to be A, will repeat itself, and the 8 is going to go in one fraction, and the 14 will go in the other. I'm going to multiply across, so I have A squared. 14 times 8 is 112. Square root. The square root of 112 is 10.6 when we round to the nearest tenth. And that's using the geometric mean.